Hello and welcome, fellow travelers, to the Sleepyhead Scientist. Let's start our another peaceful journey through world's most extraordinary places. Tonight, we're going to settle in together and explore one of Earth's most magnificent stories, a tale written not in books, but carved deep into stone over millions of years. Let's take a slow, gentle breath together and prepare to drift back through time to witness the creation of the Grand Canyon. If this gentle journey helps you rest, consider a quiet like or subscribe so others can find their way here too. And if you'd like, tell me where you're listening from and what time it is for you. Picture yourself now, standing at the edge of something truly breathtaking. The late afternoon sun casts long golden shadows across a vast chasm that stretches as far as the eye can see. The air is crisp and clean, carrying the faint scent of desert sage and ancient rock. Below you, layers upon layers of stone cascade downward like a great geological staircase, each band telling a different chapter in Earth's incredible story. This is the Grand Canyon, a place where time itself becomes visible, where we can literally see into the deep past of our planet. As we stand here together at this rim, feeling the solid ground beneath our feet, let's pause for a moment and let the magnitude of what we're witnessing truly sink in. The canyon stretches 277 river miles long, up to 18 miles wide, and plunges more than a mile deep into the Earth's ancient history. But tonight, we're not just here as tourists taking photographs. We're time travelers, ready to embark on a journey that spans nearly 2 billion years. We're going to witness the slow, patient work of water and wind, the rise and fall of ancient seas, the march of countless creatures across prehistoric landscapes, and the gradual sculpting of one of the world's most awe-inspiring natural wonders. Let's take another slow breath together and feel ourselves relaxing into this story. There's no rush here, no hurry. We have all the time in the world, literally millions and millions of years, to understand how this incredible place came to be. The Grand Canyon teaches us about patience, about the power of small, persistent forces working over vast spans of time. Drop by drop, grain by grain, year by year, this masterpiece was created. As we begin our journey tonight, imagine that we have the magical ability to watch the entire story unfold like a beautiful slow-motion movie. We'll see mountains rise from ancient seas, rivers carve their patient paths through solid stone, and life itself evolve and change in the landscapes around this growing canyon. We'll witness ice ages come and go, climates shift and change, and through it all, the steady, constant work of erosion and time. The story we're about to explore is one of the most complete geological records on Earth. Layer by layer, the canyon reveals secrets that scientists have spent lifetimes trying to understand. Each colorful band of rock, the bright red sandstones, the gray limestones, the dark schists and granites, represents a different period in our planet's history, a different chapter in the grand story of life on Earth. Tonight, as we journey through this story together, we'll learn about forces so vast and slow that they dwarf human understanding, yet so persistent and powerful that they can carve through solid mountain ranges. We'll discover how ancient seas once covered what is now desert, how mighty rivers changed their courses, and how the very ground we walk on is constantly, slowly changing beneath our feet. So let's settle in comfortably now. Close your eyes if you'd like, and let your imagination carry you back to a time long before humans walked the earth, to a time when our planet was young and wild and full of possibilities. Let's take one more deep, peaceful breath together and begin our million-year story of the Grand Canyon. The wind whispers softly across the rim where we stand, carrying with it the ancient songs of stone and time. Are you ready to listen? Are you ready to travel back through the ages and witness one of nature's greatest masterpieces taking shape? Then let's begin our journey into the deep time of the Grand Canyon, where every layer has a story to tell, and every story connects us to the incredible, patient artistry of our living planet. Let's begin our journey at the very bottom of the Grand Canyon, in the deepest, darkest rocks that form the foundation of this entire story. We're traveling back now, back through time to nearly 2 billion years ago, to an Earth that would be completely unrecognizable to us today. Take a slow, gentle breath, and let yourself drift back to this ancient world. Imagine the Earth as it was then, a planet still finding its shape, still learning how to be the world we know. The atmosphere was different, the very chemistry of life was different, and the forces that shaped the land were raw and powerful beyond our modern understanding. This was the Precambrian era, a time that encompasses most of Earth's history, stretching from the planet's formation until about 540 million years ago. Deep in the inner gorge of the Grand Canyon, we can still touch these ancient rocks today. The Vishnu schist, as geologists call it, forms the dark, twisted foundation upon which everything else was built. These rocks began their story not as the hard, metamorphosed stone we see today, but as sediments settling on the bottom of even more ancient seas, and as volcanic rocks cooling from primordial fires. Let's watch this ancient drama unfold in our mind's eye. Picture vast oceans of a blue-green color we've never seen in our modern world, tinged with different gases, different minerals, different forms of early life. On the shores of these ancient seas, volcanoes belched and roared, sending rivers of lava flowing into the waters, creating great clouds of steam that rose into the alien sky. Slowly, patiently, over millions of years, layers of sediment accumulated on the ocean floor. Tiny particles of sand and clay, the microscopic shells of primitive organisms, volcanic ash carried by ancient winds. All of it settling grain by grain into thick layers on the sea bottom. This was the beginning of what would one day become the Vishnu schist, though it would undergo incredible transformations before reaching its final form. Take another peaceful breath, and let yourself feel the vastness of the timescales we're exploring. Millions of years passed like pages turning in a cosmic book. The early sediments compressed under their own weight, slowly hardening into rock. Then came the next chapter in this ancient story, the forces of mountain building. Deep beneath the Earth's surface, tremendous pressures and temperatures began to work their magic on these ancient rocks. The process we call metamorphism began, the transformation of existing rocks into entirely new forms through heat, pressure, and chemical changes. The original sedimentary layers were folded, twisted, compressed, and heated until they became something entirely different. Imagine the rocks themselves as being kneaded like clay in the hands of a cosmic sculptor. Under pressures we can barely comprehend, and temperatures hot enough to melt metal, the ancient sediments recrystallized into new mineral forms. Quartz and feldspar, mica and hornblende, the minerals that make up schist, formed in conditions deep within the Earth's crust. But the story doesn't end there. These metamorphic rocks were then invaded by molten granite, pushing up from even deeper within the Earth. Picture streams of liquid rock, glowing white-hot, forcing their way through cracks and weaknesses in the schist, cooling slowly to form the Zoroaster granite that we can see today interlaced with the darker schist, like veins of light through shadow. The granite tells us about a time of intense geological activity, when the Earth's crust was unstable and mobile, when continents were forming and reforming, when the very foundations of our modern world were being laid down. These granite intrusions, cooled slowly over hundreds of thousands of years deep within the Earth's crust, creating the beautiful light-colored bands we see threading through the dark schist today. Let's pause here for a moment and marvel at what these ancient rocks represent. They are among the oldest exposed rocks in North America, windows into an Earth that existed when life itself was just beginning to experiment with complex forms. When these rocks were forming, the most complex life on Earth consisted of simple microbes and algae. There were no plants on land, no animals walking or swimming or flying. The very oxygen we breathe was just beginning to accumulate in the atmosphere. The formation of these Precambrian rocks involved mountain-building episodes that make our modern earthquakes look like gentle tremors. Entire continents collided and merged, creating mountain ranges that may have dwarfed even the modern Himalayas. The rocks we see today in the inner gorge are the deeply buried roots of these ancient mountains, exposed now after billions of years of erosion have stripped away miles of overlying rock. As we stand in our imaginations at the bottom of the Grand Canyon, touching these ancient rocks, we are touching the very foundation of the North American continent. These rocks were already ancient when the first complex life forms appeared in the oceans. They had already endured hundreds of millions of years of geological history when the first fish began to swim in Paleozoic seas. The colors of these rocks tell their own stories. The dark grays and blacks of the schist speak of their origin in ancient muds and volcanic materials. The lighter pinks and grays of the granite tell of their birth in the Earth's deep furnaces. Together, they form a basement complex that would provide the stable foundation for everything that was to come. But even these most ancient rocks show us the power of erosion and time. After their formation deep within the Earth, they were slowly uplifted and exposed at the surface. For perhaps 1 billion years, wind and water worked patiently to wear them down, creating a relatively flat, ancient landscape. This great wearing down created what geologists call the Great Unconformity, a gap in the rock record representing hundreds of millions of years of missing history. As our first chapter in the Grand Canyon story draws to a close, let's take another slow, peaceful breath and appreciate the incredible journey these rocks have taken. From their birth in ancient seas, through their transformation in the Earth's deep furnaces, to their eventual exposure at the surface, they represent nearly half of Earth's entire history. They remind us that our planet is not a static, unchanging place, but a dynamic, living world where even the most solid-seeming rocks are constantly, slowly, patiently changing. These Precambrian rocks form the unshakable foundation upon which the rest of our Grand Canyon story will unfold. They are the prologue to an even grander tale, the deep bass notes in a geological symphony that will play out over the next 1.5 billion years. As we prepare to move forward in time to witness the next chapters in this incredible story, let's carry with us an appreciation for these ancient foundations and the vast scales of time they represent. Now we journey forward through hundreds of millions of years to witness one of the most dramatic chapters in the Grand Canyon story. Let's take a gentle breath together and prepare to watch as ancient seas return to cover this landscape, bringing with them an explosion of life unlike anything Earth had ever seen before. We find ourselves now at a moment roughly 550 million years ago, standing on the weathered surface of those ancient Precambrian rocks we just visited. But what a different world this is from the one that created the basement rocks below. The long period of erosion that followed the exposure of the ancient schists and granites has created a relatively flat, worn-down landscape, stretching to the horizon in every direction. This moment represents one of the most significant features in the Grand Canyon's geological story. the great unconformity. Imagine looking at the canyon wall and seeing the place where dark, twisted, ancient rocks meet horizontally layered younger rocks above. This contact represents an almost incomprehensible gap in time, perhaps 300 million years of Earth's history that simply isn't recorded in the rock layers. It's as if someone tore out hundreds of pages from the middle of a book. But now, as we watch through the lens of deep time, something magnificent is about to happen. The climate is warming, ice caps that may have existed are melting, and sea levels around the world are beginning to rise. Slowly, imperceptibly at first, but then with increasing momentum, the ocean begins to creep inland across the ancient, weathered landscape. Picture the scene. Shallow, warm seas advancing across what is now the American Southwest. These aren't the deep, cold oceans we know today, but warm, tropical waters teeming with life forms that seem almost alien to our modern eyes. The water is crystal clear in some places, murky with life in others. Strange creatures move through these ancient seas, some familiar in their basic forms, others utterly unlike anything alive today. Take another slow, peaceful breath, and let yourself witness the patient advance of this Paleozoic sea. Year by year, century by century, the water level rise and the shoreline moves inland. What was once dry land becomes shallow sea floor. What was once weathered mountain becomes submerged reef. In these warm, shallow waters, life is undergoing one of the most dramatic expansions in Earth's history: the Cambrian explosion. Creatures with shells and hard parts are evolving for the first time, leaving behind fossils that we can find and study today. Trilobites scuttle across the sea floor on their many legs, their compound eyes scanning the water for food and danger. Brachiopods and early mollusks filter nutrients from the water. Primitive corals begin building the first reefs. As these seas advance and retreat over millions of years, they leave behind layer upon layer of sediment. Each layer tells a story of the conditions that existed when it was deposited. The Tapeats sandstone, the first layer deposited on top of the Great Unconformity, speaks of beaches and shallow coastal waters. Its coarse grains of quartz sand tell us about waves washing back and forth, sorting and depositing the eroded remains of ancient mountains. Let's watch as this ancient beach environment gives way to deeper waters. The sea continues to rise, or perhaps the land is slowly sinking. The result is the same. The sandy beach environment is replaced by deeper, muddier waters further from shore. Here, the bright Angel Shale is deposited, fine particles of clay and silt settling slowly through the water column to accumulate on the sea floor. The colors of these rocks paint a picture of their environment. The greens and grays of the bright Angel Shale suggest relatively oxygen-poor conditions on the sea floor, where organic matter could accumulate without completely decomposing. Occasional thin layers of sandstone within the shale tell us about storms that stirred up the sea floor, or perhaps brief periods when the water became shallower and sand could reach this far from shore. As we continue our journey through Paleozoic time, the seas continue to deepen and become even more tropical. Now we witness the deposition of the Muave limestone, formed in clear, warm waters where lime-secreting organisms thrived. Picture vast underwater gardens of primitive corals and algae, their calcium carbonate skeletons slowly building up layer by layer on the sea floor. These limestone layers preserve a record of life that is both alien and familiar. Crinoids, sea lilies, swayed in the ancient currents like underwater flowers, though they were actually animals related to starfish and sea urchins. Their broken stem segments accumulated in great beds on the sea floor. Brachiopods, superficially similar to clams, but actually very different creatures, filtered food from the water with feathery appendages. But the story of these Paleozoic seas is not one of steady, unchanging conditions. The rock layers tell us of advancing and retreating shorelines, of periods when the seas were clear and warm, and other times when muddy rivers brought sediment from distant mountains. Each change in rock type, from sandstone to shale to limestone, represents a change in environmental conditions that lasted for thousands or millions of years. Take a moment to breathe deeply and contemplate the vastness of this aquatic age. For over 200 million years, seas advanced and retreated across this landscape. Mountains rose and were worn down in distant places, sending their eroded remains to accumulate in these shallow seas. Climate patterns we can barely imagine created conditions where vast reefs could grow in what is now desert country. The Temple Butte limestone, formed about 385 million years ago, tells us about another phase of this marine story. By this time, fish had evolved and were swimming in these ancient seas. The first forests were beginning to colonize the land, though the Grand Canyon area itself remained submerged. This limestone layer is thinner and less continuous than others, suggesting that the seas may have been shallower or more variable during this period. Then came one of the most dramatic chapters in the Paleozoic story, the deposition of the Red Wall limestone. This massive layer, up to 700 feet thick in places, represents a time when clear, tropical seas covered the entire region. The limestone is actually gray when fresh, but staining from overlying iron-rich rocks has given it the distinctive red color that makes it such a prominent feature in the canyon walls today. The Red Wall limestone preserves a rich record of marine life from about 340 million years ago. Crinoids were so abundant that their broken stems make up much of the rock. Corals built patch reefs in the shallow waters. Fish swam overhead, while bottom-dwelling creatures like trilobites, though less diverse than in earlier times, still scuttled across the sea floor. But change was coming to this underwater world. As we move higher in the rock sequence, the limestones begin to give way to different types of sediment. The Supai group, deposited between about 315 and 285 million years ago, tells a story of changing conditions. Sometimes marine, sometimes terrestrial, these rocks record a time when the area was transitioning between sea and land as global climate patterns shifted. By the time we reach the end of the Paleozoic era, about 250 million years ago, the great age of marine deposition in the Grand Canyon region was coming to an end. The seas that had covered this area for so long were retreating, and new types of environments were beginning to dominate the landscape. As we conclude this chapter of our journey, let's take another peaceful breath and marvel at what we've witnessed. Over the course of nearly 300 million years, we've watched this landscape transform from ancient, weathered mountains to the bottom of a tropical sea, and then slowly emerge again. We've seen the rise and flourishing of complex life in Earth's oceans. We've witnessed the patient accumulation of thousands of feet of sediment, layer by layer, year by year, creating the foundation for the canyon walls we see today. The Paleozoic rocks of the Grand Canyon represent one of the most complete records of ancient marine life in North America. Each layer is a chapter in the story of life's expansion and diversification in Earth's oceans. From the simple creatures of the Cambrian to the more complex ecosystems of the later Paleozoic, these rocks preserve a record of evolution and environmental change that scientists are still working to fully understand. Now we must leap forward through time once again, traveling through millions of years to reach a pivotal moment in our Grand Canyon story. Take a slow, calming breath with me, and prepare to witness the birth of the force that would carve the magnificent canyon we know today, the Colorado River. We find ourselves now in a world about 70 million years ago, near the end of the age of dinosaurs. The landscape of what would become the American Southwest is vastly different from what we see today. Where the Grand Canyon will one day stand, there is instead a relatively flat plain covered by the deposits of ancient seas and rivers. The great Paleozoic seas have long since retreated, and newer rocks have been laid down on top of the marine layers we just explored. But tremendous forces are stirring beneath the surface of the Earth. Far to the west, along what is now the coast of California, oceanic plates are colliding with the North American continent, creating mountain ranges and uplifting vast areas of the interior. This period of mountain building, known as the Laramide orogeny, is beginning to reshape the entire western part of North America. Picture the scene. The Earth's crust is slowly buckling and warping under immense pressure. What was once relatively flat terrain is being pushed upward, creating highlands and basins, ridges and valleys. The Colorado Plateau, the high, stable region where the Grand Canyon will eventually form, is being born during this time of geological upheaval. Let's watch as this ancient landscape responds to the growing pressure from the west. Slowly, almost imperceptibly at first, the land begins to rise. Not violently, like during an earthquake, but gradually, over millions of years. The rocks we've been following in our story, the Paleozoic limestones and sandstones, are carried upward along with everything else, remaining relatively undisturbed but gaining elevation above sea level. Take another peaceful breath and let yourself feel the vastness of this gradual uplift. Year by year, foot by foot, the Colorado Plateau rises higher into the sky. As it rises, the climate begins to change. What was once near sea level, warm and humid, becomes higher and drier. The plant and animal life must adapt or migrate, and the very processes that shape the landscape begin to change as well. With the land now elevated above sea level, a new force becomes dominant in shaping the landscape. Running water. Rivers and streams begin to establish themselves across the newly uplifted terrain, following the natural contours of the land, seeking always the easiest path downhill toward the distant sea. But here's where our story becomes truly fascinating. The Colorado River, as we know it today, is actually a relatively young river, much younger than the rocks it cuts through. The birth of the Colorado River system is one of the most complex and debated topics in geology, a puzzle that scientists are still working to solve completely. For millions of years during the early stages of plateau uplift, the drainage patterns in this region were completely different from what we see today. Instead of one great river flowing toward the Gulf of California, there were multiple smaller river systems flowing in different directions. Some flowed northeast toward what is now the Gulf of Mexico. Others flowed northwest toward ancient lakes in Nevada and Utah. Picture this ancient landscape, a high plateau dissected by multiple river systems that don't yet connect to form the integrated drainage network we know today. These early rivers are already beginning the work of erosion, cutting small canyons and valleys into the uplifted rocks. But the Grand Canyon itself doesn't yet exist, because the Colorado River doesn't yet exist in its modern form. The key moment in our story comes roughly 5 to 6 million years ago, a mere instant in geological time. This is when the various river systems that had been draining different parts of the plateau began to connect and integrate into the single powerful river system we know today as the Colorado River. But how did this integration happen? Let's slow down and watch this crucial transformation unfold. Imagine a river system flowing from the Rocky Mountains westward across what is now Utah and Colorado. This ancient river, which geologists call the ancestral Colorado River, was flowing toward ancient lakes in Nevada, not toward the ocean. At the same time, in what is now Arizona, another river system was working its way upstream, cutting headward into the plateau from the southwest. This river had a connection to the sea. It could flow all the way to the Gulf of California. As it cut headward, following zones of weakness in the rock, it was slowly approaching the ancient lake-bound river system from the other direction. Take a moment to breathe deeply and picture this dramatic moment of connection. After millions of years of separate evolution, these two river systems finally meet. The exact mechanism is still debated by scientists. It might have happened through the capture of one river by another, or through the overflow of ancient lakes, or through a combination of factors. But when the connection was made, the results were dramatic. Suddenly, all the water that had been flowing into closed basins in the interior of the continent had a new pathway to the sea. The integrated Colorado River was born, and with it came a tremendous increase in the erosive power available to carve into the Colorado Plateau. Think about what this means. Instead of several smaller rivers working independently, there was now one large river system with the combined erosive power of all the water draining the southern Rocky Mountains, the Colorado Plateau, and tributary areas. This newly integrated river had both the volume of water and the gradient necessary to begin the serious work of canyon cutting. The timing of this river integration coincides remarkably well with the evidence for when the Grand Canyon itself began to form. Using techniques like dating cave formations and analyzing the chemistry of ancient deposits, scientists have determined that the major phase of Grand Canyon cutting began roughly 5 to 6 million years ago, the same time frame as the birth of the modern Colorado River system. But the story is even more complex than simple river capture. Climate changes during this period also played a crucial role in shaping the Colorado River's behavior. The late Miocene and early Pliocene epochs, when the river was integrating, were times of significant climate change. Cooling global temperatures were leading toward the ice ages that would dominate the later Cenozoic era. These climate changes affected precipitation patterns across the western United States. Some periods brought increased rainfall and snowfall to the Rocky Mountains, providing more water for the river system. Other periods were drier, concentrating the river's flow and increasing its ability to cut downward, rather than spreading across a wide floodplain. Let's watch as this newly born river begins its work. Picture the Colorado River in its earliest days as an integrated system, a powerful, muddy torrent carrying tremendous loads of sand, gravel, and boulders eroded from the Rocky Mountains and the plateau itself. This is not the relatively clear, controlled river we see today below the modern dams, but a wild, seasonal flood and drought cycle river that could vary enormously in flow from season to season and year to year. The river's path across the Colorado Plateau was not predetermined. Water always seeks the easiest route downhill, but easiest in geological terms can be complex. The river followed zones of weakness in the rock, areas where the stone was fractured, where different rock types met, where ancient faults provided natural pathways for erosion. As we conclude this chapter of our Grand Canyon story, let's take another slow, peaceful breath and contemplate what we've witnessed. We've seen the birth of one of North America's great rivers, not through a single dramatic event, but through the slow integration of multiple river systems over millions of years. We've watched as the Colorado Plateau was uplifted to provide the elevation difference necessary for canyon cutting, and we've seen how climate changes created the conditions that would allow for rapid erosion. The birth of the Colorado River represents a turning point in our story. Until this moment, the Grand Canyon region had been shaped primarily by deposition, the accumulation of sediment in ancient seas and on floodplains. But with the integration of the Colorado River system, erosion became the dominant force. The river now had both the power and the pathway to begin carving the magnificent canyon that would become one of the world's greatest natural wonders. Now comes the most dramatic chapter in our Grand Canyon story, the moment when the newly born Colorado River began its patient, persistent work of carving through solid rock. Take a deep, restful breath with me and prepare to witness one of nature's most incredible demonstrations of the power of water over stone. We join our story about 5.5 million years ago, just as the integrated Colorado River has established its course across the Colorado Plateau. Picture this ancient river, not the dammed and controlled waterway we see today, but a wild, untamed torrent that varied dramatically with the seasons. During spring snowmelt, it roared through the landscape carrying enormous loads of sediment and debris. During dry periods, it might slow to a relative trickle, but it never stopped its patient work. The river's path took it directly across the uplifted Colorado Plateau, cutting perpendicular to the rock layers that had been laid down over hundreds of millions of years. This was not the easiest route for the river to take. It would have been much simpler to flow around the plateau rather than through it. But the river was what geologists call antecedent. It had established its course before the major uplift occurred, and as the land rose beneath it, the river kept pace by cutting downward. Let's slow down time and watch this incredible process unfold. Imagine looking down from high above as the river begins its work. At first, there's no canyon at all, just a river flowing across a relatively flat, elevated landscape. The water moves swiftly, carrying with it a heavy load of sand, gravel, and boulders picked up from the Rocky Mountains and from the riverbed itself. This sediment load is crucial to understanding how the canyon formed. The river water alone, even flowing rapidly, could not carve through solid rock. But water carrying abrasive particles of sand and rock becomes a powerful cutting tool. Picture it like a liquid sandpaper, with millions of sand grains acting as tiny chisels, constantly scraping and grinding away at the riverbed. Take another slow, peaceful breath, and let yourself witness the beginning of this great carving. Year by year, the river cuts deeper into the rock. The process is so gradual that if you could stand on the riverbank for a human lifetime, you might not notice any change at all. But over thousands of years, then tens of thousands, then millions of years, the accumulated effect becomes dramatic. The river doesn't cut straight down like a knife through butter. Instead, it follows the natural weaknesses in the rock, the joints and fractures that exist in all stone formations. Water seeps into these cracks, freezing and expanding in winter, gradually widening the openings. The river exploits these weaknesses, gradually enlarging them into channels and gorges. As the river cuts deeper, something fascinating begins to happen. The canyon walls start to retreat through the process we call weathering and mass wasting. Rain falls on the exposed rock faces, seeping into cracks and joints. Temperature changes cause the rock to expand and contract, gradually loosening pieces. Gravity pulls the loosened material down into the river, where it's carried away as part of the sediment load. Different rock layers respond differently to this weathering process, creating the distinctive stepped profile we see in the Grand Canyon today. The hard, resistant layers like the Red Wall limestone and the Coconino sandstone form vertical cliffs. The softer layers like the Bright Angel shale form gentle slopes where weathered material accumulates before being washed away by occasional storms. Let's zoom in on this process and watch it happen in slow motion. Picture a cliff face of Red Wall limestone towering above the river. Water seeps into the horizontal joints that separate the limestone layers. During cold nights, this water freezes and expands, creating tremendous pressure that gradually widens the cracks. Eventually, entire blocks of limestone break away and tumble into the river below. But the river doesn't just carry away the fallen rocks. It grinds them up, turning huge boulders into smaller stones into pebbles, pebbles into sand, and sand into fine silt. This newly created sediment becomes part of the river's cutting tool, helping it carve even deeper into the remaining rock. The rate of this cutting process varied tremendously over time, depending on several factors. During periods of high precipitation in the Rocky Mountains, the river carried much more water and sediment, allowing it to cut more rapidly. During drier periods, the cutting slowed but never stopped entirely. Climate changes also played a crucial role in the carving process. As global temperatures cooled toward the ice ages, precipitation patterns changed across the American Southwest. Some periods brought increased snowfall to the high mountains, creating more powerful spring floods. Other periods brought different seasonal patterns that affected how the river behaved throughout the year. Take a moment to breathe deeply and contemplate the incredible persistence required for this process. Imagine the Colorado River flowing day after day, year after year, century after century, millennium after millennium, never stopping its patient work of erosion. Through ice ages and warm periods, through volcanic eruptions and climate changes, through the evolution and extinction of countless species, the river kept flowing and cutting. By about 4 million years ago, the river had already carved a substantial canyon, perhaps half as deep as the modern Grand Canyon. The basic outline was beginning to take shape, with the river cutting through the Paleozoic rock layers we explored earlier, gradually working its way down toward the ancient Precambrian basement rocks. As the canyon grew deeper, it began to create its own microclimate. The inner gorge, protected from wind and receiving intense reflected sunlight from the canyon walls, became significantly warmer than the rim. This temperature difference affected weathering rates and created the diverse ecosystem zones that characterize the canyon today. The river's course wasn't fixed during this period of initial carving. Occasionally, the river would shift its channel slightly, perhaps during a particularly large flood or when a rockfall temporarily dammed the flow. These channel changes can still be seen today in the form of abandoned terraces and benches carved into the canyon walls, evidence of where the river used to flow at higher levels. One of the most remarkable aspects of this carving process is how it revealed Earth's geological history layer by layer. As the river cut deeper, it exposed progressively older rocks, creating a perfect cross-section through hundreds of millions of years of Earth history. Each newly exposed layer told scientists about different periods in our planet's past. The river's cutting action was not uniform across all rock types. When it encountered particularly hard rocks like the Vishnu schist in the inner gorge, the cutting slowed dramatically. When it reached softer rocks, it could carve more quickly. This is why the inner gorge, carved into the hard metamorphic basement rocks, is so narrow compared to the upper parts of the canyon carved into sedimentary rocks. By about 2 million years ago, the river had cut most of the way through the sedimentary rock layers and was beginning to encounter the ancient Precambrian rocks at the bottom. This marked a significant change in the carving process, as these metamorphic rocks were much harder and more resistant to erosion than the sedimentary layers above. The encounter with the Precambrian basement created the distinctive inner gorge that characterizes the deepest part of the modern Grand Canyon. Here, the river's cutting slowed dramatically, but it never stopped. The hard schist and granite forced the river into a narrow, winding channel quite different from the broader canyon carved in the softer rocks above. As we watch this great carving process unfold over millions of years, we can see how the Colorado River became both the creator and the sculptor of the Grand Canyon. Every flood, every seasonal cycle, every grain of sand carried downstream contributed to this monumental work of natural architecture. The river was simultaneously destroying the landscape by cutting through it and creating one of the world's most beautiful natural wonders. The initial carving phase of the Grand Canyon represents one of the most rapid and dramatic examples of landscape change in Earth's geological record. In just a few million years, a brief moment in geological time, The Colorado River had carved through thousands of feet of solid rock, creating a canyon that already rivaled many of the world's great gorges. But this was only the beginning. The basic structure of the canyon was now established, but millions of years of refinement, widening, and deepening lay ahead. Ice ages would come and go, climate would change, and the patient work of erosion would continue to shape and reshape this magnificent landscape. Let's take one more peaceful breath and marvel at what we've witnessed. We've watched the birth of one of Earth's greatest canyons, carved not through violent catastrophe, but through the patient, persistent work of flowing water. We've seen how the Colorado River, following the simple law of gravity, created something far more complex and beautiful than any human architect could design. Now we enter a new phase of our Grand Canyon story, one marked by dramatic swings in Earth's climate that would profoundly affect both the river and the canyon it was carving. Take a slow, calming breath and prepare to witness how ice ages thousands of miles away would influence the very formation of this desert canyon. We find ourselves now about 2.5 million years ago, at the beginning of the Pleistocene epoch, the Great Age of Ice. Far to the north, massive glaciers are beginning to form and advance across much of Canada and the northern United States. These ice sheets, in some places more than a mile thick, seem far removed from the warm desert landscape of the Grand Canyon region, but their influence on our story will be profound and far-reaching. Picture the Earth during this time as a planet in the grip of dramatic climate oscillations. Over periods of roughly 100,000 years, the planet swings between ice ages, when glaciers advance far south into the continental United States, and interglacial periods when the climate is similar to or even warmer than today. These cycles are driven by subtle changes in Earth's orbit around the Sun, changes so small they seem insignificant, but which have enormous consequences for global climate. Let's watch how these distant ice sheets affect our desert canyon. During ice ages, vast amounts of water are locked up in continental glaciers, causing sea levels around the world to drop by hundreds of feet. This lowering of sea level has a direct effect on the Colorado River. It increases the gradient, or steepness, of the river's path to the ocean, giving it more erosive power. But the effects go far beyond simple changes in gradient. The ice ages also dramatically alter precipitation patterns across western North America. During glacial periods, storm tracks shift southward, bringing more moisture to the American Southwest. The Rocky Mountains, the source of the Colorado River, receive much more snow and rainfall during these periods. Take another peaceful breath and imagine the Colorado River during an ice age. Instead of the relatively modest flow we see in modern times, the river becomes a much more powerful force. Spring snowmelt creates massive floods that roar through the canyon, carrying enormous loads of sediment and debris. These glacial age floods have cutting power far beyond anything the river achieves during warmer, drier periods. The increased flow during ice ages accelerates the canyon cutting process dramatically. What might take 100,000 years to erode during normal conditions might be accomplished in just 10,000 years during a glacial period. The ice ages, paradoxically, become the primary drivers of erosion in this desert landscape. But the story becomes even more complex when we consider what happens between ice ages. During interglacial periods like the one we live in today, the climate becomes warmer and drier. The great continental ice sheets retreat, sea level rises, and precipitation patterns shift again. The Colorado River's flow decreases, but its character changes in other important ways. With less water but still carrying sediment from upstream, the river during interglacial periods tends to deposit material rather than erode it. Terraces of sand and gravel are left behind on the canyon walls, marking the river's level during these quieter periods. These terraces, which we can still see today, provide a record of the river's changing behavior over the past 2 million years. Let's slow down and observe one complete glacial cycle. We begin during an interglacial period, with the river flowing at relatively low levels, depositing sediment and building terraces. Gradually, as orbital cycles shift Earth toward cooler conditions, snow begins to accumulate more persistently in high mountain areas. The Colorado River's flow begins to increase as more precipitation falls in its watershed. As the climate continues to cool, the increased river flow begins to cut through the terraces deposited during the previous interglacial period. The river starts to downcut more rapidly, carving deeper into the canyon floor. This cutting phase can last for thousands of years as the climate reaches its coldest point and glacial conditions become fully established. Picture the river during peak glacial conditions, a muddy, powerful torrent carrying tremendous loads of sand, gravel, and boulders. Spring floods are particularly dramatic, as vast amounts of snowmelt from the Rocky Mountains funnel through the canyon system. These floods have the power to move boulders the size of houses, constantly reshaping the riverbed and canyon walls. Take a moment to breathe deeply and contemplate the cyclical nature of this process. Over the past 2 million years, the Earth has experienced roughly 20 major glacial cycles, each one lasting about 100,000 years. Each cycle brought a period of enhanced erosion, followed by a period of relative stability and deposition. This cyclical pattern helps explain some puzzling features of the modern Grand Canyon. If erosion had been constant over the past 5 million years, we might expect the canyon to be much deeper than it actually is. But the Ice Age cycles meant that major erosion occurred only during relatively brief periods when glacial conditions enhanced the river's cutting power. The Ice Ages also affected the canyon in more subtle ways. Changes in precipitation patterns altered the types of weathering that affected the canyon walls. During glacial periods, increased freeze-thaw cycles helped break up rock faces, providing more material for the river to carry away. During interglacial periods, chemical weathering became more important as higher temperatures accelerated the breakdown of minerals in the rock. Plant and animal life in the Grand Canyon region also responded dramatically to these climate cycles. During glacial periods, species that we now associate with much higher elevations or more northern latitudes lived in the canyon. Spruce and fir forests grew where desert scrub exists today. During interglacial periods, desert species expanded their ranges and cold-adapted species retreated to higher elevations or more northerly areas. These biological changes are preserved in the geological record of the canyon. Fossil pollen in ancient lake beds tells us about past vegetation. Cave deposits preserve the bones of animals that lived in the area during different climate periods. Pack rat middens, ancient accumulations of plant material collected by these industrious rodents, provide detailed records of how plant communities changed over thousands of years. The most recent Ice Age, which ended only about 11,000 years ago, had particularly dramatic effects on the Colorado River and the Grand Canyon. During this period, called the last glacial maximum, ice sheets extended as far south as present-day Kansas and Nebraska. The Colorado River carried perhaps 3 to 5 times as much water as it does today, creating some of the most recent major erosional features in the canyon. Evidence of these recent high flows can be seen throughout the Grand Canyon today. High water marks on canyon walls show where floodwaters reached levels hundreds of feet above the current river level. Boulder deposits inside canyons mark where these ancient floods deposited material that the river could no longer carry as floodwaters receded. As the last ice age ended and we entered the current interglacial period, the Colorado River's behavior changed dramatically. Reduced precipitation in the Rocky Mountains meant less water flow. Rising sea levels reduced the river's gradient. The result was a river with much less erosive power than during glacial times. This reduction in the river's cutting ability means that most of the major canyon carving occurred during the ice ages of the past 2 million years, not during the initial establishment of the River 6 million years ago. The ice ages transformed the Colorado River from a modest canyon-cutting river into a powerful erosional force capable of carving one of the world's great gorges. But the ice ages brought more than just increased water flow. They also created the complex terrace systems that characterize parts of the modern canyon. Each glacial cycle left behind evidence of the river's changing levels, creating a staircase-like pattern of terraces that record the river's history over hundreds of thousands of years. The timing of these terraces provides crucial evidence for understanding how the canyon formed. By dating terrace deposits using various techniques, scientists can determine when the river flowed at different levels and how rapidly it was cutting downward during various periods. As we conclude this chapter of climate-driven canyon carving, let's take another slow, restful breath and reflect on the remarkable story we've witnessed. We've seen how events thousands of miles away, the advance and retreat of continental ice sheets, profoundly influenced the carving of a desert canyon. We've watched as the Earth's orbital cycles created dramatic swings in erosional power that shaped one of our planet's most magnificent landscapes. The ice ages remind us that the Earth's climate system is interconnected in ways that can produce surprising results. Who would have imagined that ice sheets in Canada and the northern Midwest would be crucial to carving a canyon in Arizona? This interconnectedness continues today, as changes in global climate patterns affect river systems around the world. Now let's turn our attention to the living story of the Grand Canyon, the incredible parade of plants and animals that have called this landscape home over millions of years. Take a gentle, peaceful breath and prepare to meet some of the most remarkable creatures that ever lived in and around this ancient landscape. As we journey back to the early days of canyon formation, about 5 million years ago, we find ourselves in a world where the climate was generally warmer and more humid than today. The landscape that would become the Grand Canyon was covered not with desert scrub and pinyon pine, but with subtropical forests that would seem utterly foreign to modern visitors. Picture this ancient ecosystem. Lush woodlands of oak and maple stretched across the Colorado Plateau, while palm trees grew along the riverbanks. In these warm, humid forests lived creatures that seem almost mythical to us today. Early horses no bigger than dogs, with multiple toes instead of hooves, browsers that fed on the abundant vegetation. Camels, yes, camels, roamed North America in great diversity during this period, some as large as modern giraffes, others small and gazelle-like. Let's pause here for a moment, and let our imagination fill in this ancient scene. Along the banks of the young Colorado River, 3-toed horses come down to drink in the evening light. In the distance, a herd of early camels moves through the woodland, their long necks stretching to reach tender leaves. This is millions of years before the harsh desert landscape we associate with the region today. In the waters of the ancient Colorado River swam fish quite different from the species we find today. Giant salamanders, relatives of species that still live in Asia, lurked in quiet backwaters. Freshwater sharks, yes, sharks in the Colorado River, preyed on other fish in the muddy waters. These were not the marine sharks we think of today, but specialized freshwater species that evolved to live in river systems. As the canyon began to deepen and the climate started to cool toward the ice ages, this subtropical paradise gradually gave way to different plant and animal communities. The cooling climate pushed warm-adapted species southward or into extinction, while species adapted to cooler, drier conditions began to colonize the region. By about 3 million years ago, the Grand Canyon ecosystem was beginning to resemble something more familiar, though still quite different from today. Grasslands were expanding at the expense of forests. The first true deer appeared, along with early bears that were smaller and more primitive than modern species. Saber-toothed cats prowled these ancient landscapes, their distinctive canine teeth adapted for killing large prey. Take another slow breath, and let yourself witness one of the most dramatic periods in the canyon's biological history. About 2 million years ago, as the ice ages began in earnest, North and South America became connected by the Isthmus of Panama. This seemingly small geographical change had enormous consequences for life throughout the Americas, including in the Grand Canyon region. The connection between North and South America allowed species to migrate between the continents for the first time in millions of years. From South America came giant ground sloths, some as large as elephants, with massive claws for stripping vegetation from trees. Glyptodonts, armadillo relatives the size of small cars, wandered north across the land bridge. Armadillos themselves, though much smaller, also made the journey north. But the migration went both directions. From North America, horses and camels migrated south. Ironically, both groups would later become extinct in North America, but survive in other parts of the world. Cats, dogs, and bears also spread southward, dramatically changing South American ecosystems. In the Grand Canyon region, this great interchange brought new predators and new prey species. Giant, short-faced bears, standing 12 feet tall on their hind legs, became the dominant carnivores. These massive bears were not the fish-eating, berry-picking bears we know today, but powerful hunters capable of taking down the largest prey animals. The ice ages themselves created a constantly shifting mosaic of ecosystems in the Grand Canyon region. During glacial periods, species adapted to cold climates moved far south of their current ranges. Spruce and fir forests grew where desert exists today. Caribou, musk oxen, and other Arctic animals lived in areas that now support cactus and desert bighorn sheep. Let's slow down time and watch one of these glacial periods unfold. As the climate cools, the subtropical species that had dominated the region gradually retreat southward, or to protected refugia. In their place come hardy species adapted to cold, harsh conditions. The canyon walls provide shelter for different species at different elevations, creating a complex vertical ecosystem that changes with altitude. During the coldest periods of the ice ages, the Grand Canyon region supported an amazing diversity of large mammals. Woolly mammoths and mastodons browsed in the forests. Ground sloths as tall as giraffes stripped leaves from trees with their massive claws. American cheetahs, faster even than African cheetahs, raced across the grasslands in pursuit of pronghorn antelope and early horses. The rivers and lakes of the region supported their own unique fauna. Giant beavers, as large as black bears, built dams across streams and rivers. These weren't the familiar beavers we know today, but a completely different family of rodents that happened to evolve similar dam-building behaviors. In the deeper pools lived giant pike and other fish species that have no modern equivalents. Take a moment to breathe peacefully, and imagine the sounds of this Ice Age landscape. The trumpeting of mammoths echoes across the canyon walls. The roar of giant, short-faced bears answers from the forest. In the distance, the howling of dire wolves, larger and more powerful than modern wolves, carries on the wind. But perhaps the most remarkable aspect of the Grand Canyon's Ice Age fauna was the incredible diversity of carnivores. Along with the giant bears and dire wolves, the region was home to American lions larger than modern African lions. Saber-toothed cats of several different species specialized in hunting different types of prey. Scimitar cats, with flattened, blade-like canines, were built for speed and pursuit hunting. This abundance of predators was supported by equally impressive diversity of prey animals. Along with mammoths and ground sloths, the region was home to several species of horses, camels, bison much larger than modern buffalo, and peccaries, wild pigs, that lived in large herds. The plant communities during ice ages were equally remarkable. Instead of the desert scrub that dominates the region today, much of the Colorado Plateau was covered by grasslands that supported vast herds of grazing animals. These grasslands were punctuated by gallery forests along rivers and streams, and by montane forests on the higher elevations of canyon rims. But ice ages were followed by interglacial periods, times when the climate warmed and ecosystems shifted once again. During these warmer periods, many of the cold-adapted species retreated northward or to higher elevations. Desert species expanded their ranges, and the basic patterns of modern Grand Canyon ecosystems began to emerge. The transition from ice age to interglacial was not always gradual. Sometimes climate changes happened relatively rapidly, forcing ecosystems to reorganize quickly. Species that couldn't adapt or migrate fast enough became extinct. Others found refuge in protected areas and survived to recolonize when conditions became favorable again. The end of the last ice age, about 11,000 years ago, marked a particularly dramatic turning point for Grand Canyon wildlife. Within just a few thousand years, most of the large mammals that had dominated the landscape for millions of years became extinct. Mammoths, ground sloths, giant bears, saber-toothed cats, American lions, horses, camels, all vanished from North America. The causes of these extinctions are still debated by scientists. Climate change certainly played a role, as warming temperatures eliminated many of the habitats these species depended on. But the timing of the extinctions coincides closely with the arrival of humans in North America, suggesting that hunting pressure may also have been a factor. Whatever the cause, the result was a dramatic simplification of Grand Canyon ecosystems. The diverse communities of large mammals gave way to the relatively species-poor communities we see today. Modern Grand Canyon wildlife, while still impressive, represents just a small fraction of the biological diversity that once characterized this region. But life is remarkably adaptable. As the large Ice Age mammals disappeared, other species evolved to fill some of the vacant ecological roles. Desert bighorn sheep became the dominant large mammal in the canyon itself. Elk and deer expanded their ranges. Smaller mammals like pack rats, ground squirrels, and chipmunks diversified to exploit different ecological niches. The plant communities also underwent dramatic changes as the climate warmed and dried. The grasslands and forests that had covered much of the region gave way to the desert scrub communities we see today. Cacti, which had been relatively minor components of Ice Age ecosystems, became dominant in many areas. The Colorado River itself experienced major changes in its fish fauna. Many of the large, cold-water species that had lived in the Glacial Age River became extinct as the climate warmed and river flows decreased. They were replaced by smaller, warm-water species, better adapted to the more arid conditions of the Holocene. As we conclude this chapter of life in the Grand Canyon, let's take one final peaceful breath and reflect on the incredible story of biological change we've witnessed. Over millions of years, we've watched as climate changes drove waves of extinction and evolution, creating and destroying entire ecosystems. The story of Grand Canyon wildlife reminds us that the natural world is not static, but constantly changing. The plants and animals we see in the canyon today are not the same ones that were there 1,000,000 years ago, or even 10,000 years ago. Evolution and extinction, migration and adaptation. These are the forces that shape life on Earth over long time scales. Now we come to a more recent but equally fascinating chapter in our Grand Canyon story: the arrival of humans and their deep, enduring connection to this magnificent landscape. take a slow, contemplative breath and prepare to witness how indigenous peoples discovered, explored, and made their homes in and around the canyon for thousands of years before European explorers ever glimpsed this wonder. The human story of the Grand Canyon begins roughly 12,000 years ago, near the end of the last ice age, when the first Native American peoples arrived in the region. These were the Paleo-Indians, skilled hunters and gatherers who had migrated across the Bering Land Bridge from Asia and gradually spread throughout North and South America. Picture these first human visitors to the Grand Canyon region. Small bands of families moving across a landscape still dominated by Ice Age megafauna. These early peoples witnessed the final chapters of the Pleistocene world. They may have hunted the last mammoths and giant ground sloths, sharing the landscape with saber-toothed cats and giant bears. They were among the first humans anywhere on Earth to gaze into the depths of the Grand Canyon. Archaeological evidence of these earliest inhabitants is sparse but fascinating. Stone tools and projectile points found in the region tell us that Paleo-Indians were skilled craftspeople who adapted their technology to local resources. They followed seasonal migration patterns, moving to higher elevations in summer and returning to lower, more protected areas during winter. Let's move forward in time and watch as the climate continued to warm and dry, transforming not just the landscape, but the way humans lived in it. By about 8,000 years ago, the Archaic period had begun, marked by peoples who had adapted to the increasingly arid conditions of the post-Ice Age world. Take another peaceful breath, and imagine these archaic peoples as they discovered the incredible resources hidden within the Grand Canyon's depths. Unlike the vast, open hunting grounds that had sustained the Paleo-Indians, the canyon offered a different kind of abundance. Water springs, protected caves and overhangs, and diverse plant and animal communities that varied dramatically with elevation. The archaic peoples became master foragers, developing an intimate knowledge of the canyon's seasonal cycles and resources. They knew which plants ripened when, where to find water during dry periods, and how to navigate the treacherous terrain of the inner canyon. Their split-twig figurines, small animal figures made from willow twigs found in canyon caves, represent some of the earliest known art in the region. These figurines, dating back over 4,000 years, provide a window into the spiritual lives of these ancient peoples. Many appear to represent desert bighorn sheep or deer, animals that were crucial to survival in the canyon environment. The figurines were often placed in caves deep within the canyon, suggesting they played a role in hunting rituals or ceremonies. As centuries passed, the peoples of the Grand Canyon region developed increasingly sophisticated cultures. By about 1,500 years ago, the ancestral Puebloan peoples, formerly called Anasazi, had begun to establish permanent settlements in and around the canyon. These were not simple hunter-gatherer bands, but complex societies with advanced knowledge of agriculture, architecture, and astronomy. Let's slow down and witness the remarkable achievements of these ancestral Puebloan peoples. Inside canyons and on the canyon rims, they built elaborate cliff dwellings and mesa-top pueblos. Some of these structures, like those at nearby Mesa Verde, contained hundreds of rooms and housed entire communities. The engineering skills required to build these structures in such challenging terrain was remarkable. But perhaps even more impressive was their agricultural system. In a landscape that receives less than 10 inches of rain per year, the ancestral Puebloans developed techniques for growing corn, beans, and squash. They built check dams and terraces to capture precious rainwater runoff. They selected and developed drought-resistant varieties of crops specifically adapted to the harsh conditions of the Colorado Plateau. The ancestral Puebloans also developed extensive trade networks that stretched across much of the American Southwest and beyond. Seashells from the Pacific coast, copper bells from Mexico, and turquoise from distant mines have all been found in Grand Canyon area sites, evidence of sophisticated trade relationships that connected canyon dwellers to cultures hundreds of miles away. Take a moment to breathe deeply and contemplate the spiritual significance the canyon held for these peoples. The Grand Canyon was not just a place to live or a source of resources. It was a sacred landscape imbued with deep spiritual meaning. Many contemporary Native American tribes trace their origins to the canyon, and their oral traditions preserve memories of ancestral migrations and spiritual connections to this place. For the Hopi people, whose ancestors include the ancestral Puebloans, the Grand Canyon is the place where their ancestors emerged into this world from the previous world below. The Colorado River represents the path their spirits will follow when they die, returning to the spiritual realm. The canyon is quite literally the center of their spiritual universe. By about 700 years ago, the ancestral Puebloans had largely abandoned their permanent settlements in the Grand Canyon region, migrating to areas along the Rio Grande and other river valleys where water was more reliable. The reasons for this migration are still debated, but likely included prolonged droughts, resource depletion, and possibly social conflicts. But the canyon was not abandoned. Other Native American groups moved into the region, each developing their own unique relationships with this challenging but rewarding landscape. The Southern Paiute became the dominant group on the north rim and in the western portions of the canyon. The Havasupai established themselves in the side canyons, particularly Havasu Canyon, where natural springs created an oasis in the desert. The Havasupai developed perhaps the most intimate relationship with the inner canyon of any Native American group. For over 800 years, they have lived in Havasu Canyon, a side canyon of the Grand Canyon famous for its beautiful blue-green waterfalls. The Havasupai became master agriculturalists, growing crops in the fertile canyon bottom while hunting and gathering on the rim country during certain seasons. Let's visit the Havasupai people in their canyon home. Picture Havasu Canyon in late spring. The cottonwood trees are leafing out in brilliant green, wildflowers bloom along the creek, and the famous waterfalls cascade over limestone ledges into pools of the most beautiful blue-green water imaginable. The Havasupai have created an agricultural paradise in this desert canyon, with irrigated fields of corn, beans, squash, and sunflowers. The Havasupai developed sophisticated techniques for canyon living that sustained their community for centuries. They built brush and stone shelters that provided protection from flash floods. They developed an intricate system of trails that allowed them to move safely between the canyon bottom and the rim. They learned to read the subtle signs of weather that could mean the difference between life and death in canyon country. On the south rim, the Hopi established seasonal camps where they gathered salt from deposits in the inner canyon and collected plants for food and medicine. These journeys to the canyon were often combined with religious pilgrimages, as the Hopi visited sacred sites and performed ceremonies that maintained their spiritual connection to this ancestral homeland. The Navajo also developed important connections to the Grand Canyon, though their relationship with the landscape was different from the other tribes. The Navajo are relative newcomers to the southwest, having migrated into the region from Canada, perhaps 600, 700 years ago. They developed a pastoral lifestyle based on sheep herding, but they also incorporated the canyon into their complex spiritual geography. Take another slow, peaceful breath and reflect on what these indigenous connections mean for our understanding of the Grand Canyon. For thousands of years before European exploration, this landscape was home to sophisticated human societies that developed sustainable ways of living in one of North America's most challenging environments. These Native American peoples were not just passive inhabitants of the canyon, they were active managers of its resources. They used controlled burning to maintain grasslands and encourage the growth of useful plants. They harvested animals and plants in ways that maintained ecological balance. Their presence was part of the ecosystem, not separate from it. The oral traditions of these peoples preserve detailed knowledge about the canyon that extends back many generations. Stories about past climate changes, animal behavior, plant resources, and seasonal patterns represent libraries of ecological information that complement what scientists learn from geological and archaeological evidence. When Spanish explorers first reached the Grand Canyon in 1540, they encountered not a wilderness untouched by human hands, but a landscape that had been home to indigenous peoples for millennia. The expedition of Francisco Vázquez de Coronado, led to the canyon by Hopi guides, represented the first recorded European glimpse of this wonder. But for the Hopi guides, it was simply a visit to ancestral homeland. The Spanish were impressed, but not enchanted by the canyon. They saw it primarily as an obstacle to further exploration and settlement. It would be over 300 years before European Americans would begin to appreciate the canyon for its scenic and scientific value. During those centuries, Native American peoples continued to live in and around the canyon, maintaining their ancient connections to the land. The establishment of Grand Canyon National Park in 1919 marked the beginning of a new chapter in the human story of the canyon, but it also represented a tragic disruption of indigenous relationships with the landscape. Native American peoples who had lived in the area for centuries were excluded from their traditional homeland, their access to sacred sites restricted, and their sustainable land management practices abandoned. Today, there is growing recognition of the importance of indigenous knowledge and perspectives in understanding and managing the Grand Canyon. Several tribes maintain cultural and spiritual connections to the canyon and are increasingly involved in decisions about its management and protection. Their traditional ecological knowledge provides valuable insights that complement scientific understanding. As we conclude this chapter of human connection to the Grand Canyon, let's take one final reflective breath and honor the thousands of years of human history that preceded the establishment of the canyon as a national park. The indigenous peoples who called this place home developed some of humanity's most sophisticated adaptations to arid land living, and their descendants continue to maintain sacred connections to this remarkable landscape. Now we arrive at the most recent chapter in our Grand Canyon story, the era of modern scientific discovery, and the canyon's emergence as one of the world's most celebrated natural wonders. Take a deep, satisfying breath, and prepare to witness how this ancient landscape became a laboratory for understanding Earth's history and a symbol of the power of nature conservation. Our modern chapter begins in the late 1800s, when the first scientific expeditions began to systematically explore and document the Grand Canyon. The most famous of these early expeditions was led by John Wesley Powell, a one-armed Civil War veteran who became obsessed with exploring the Colorado River and its canyons. Picture the scene in May 1869. Powell and 9 companions launched their wooden boats into the Green River in Wyoming, beginning a journey that would take them through uncharted rapids and into the heart of the Grand Canyon itself. This was not just an adventure. It was a scientific expedition designed to map the river, study the geology, and document the plant and animal life of one of the last unexplored regions of the continental United States. Let's follow Powell's expedition as they approach the Grand Canyon for the first time. After weeks of navigating through smaller canyons upstream, they suddenly find themselves at the rim of an abyss so vast and deep that it defies comprehension. Powell writes in his journal about the sublimity of the scene, struggling to find words adequate to describe what he was witnessing. Take another peaceful breath and imagine the mixture of awe and terror these explorers must have felt as they prepared to navigate their small wooden boats through the rapids of the inner gorge. They had no way of knowing what lay ahead, whether the river was navigable, whether there were waterfalls that would destroy their boats or whether they would emerge alive from the canyon's depths. Powell's expedition was revolutionary not just for its daring, but for its scientific approach to exploration. Powell was a trained geologist who recognized that the Grand Canyon offered an unprecedented opportunity to study Earth's history. As they traveled through the canyon, he carefully documented the rock layers, collected fossils, and made detailed observations about how the canyon had formed. It was Powell who first articulated the concept that became central to understanding the Grand Canyon, that this magnificent landscape had been carved by the river itself, working slowly over vast periods of time. This was a radical idea in an era when most people still believed that landscapes were created by sudden, catastrophic events rather than by gradual processes working over long periods. Powell's writings about the canyon captured the public imagination and helped establish the Grand Canyon as a symbol of American wilderness. His descriptions of the Great Unknown River and the Granite Gorge introduced millions of Americans to a landscape unlike anything else on Earth. But Powell was just the beginning of the scientific exploration of the Grand Canyon. In the decades that followed his expeditions, geologists, biologists, archaeologists, and other scientists flocked to the canyon to study its secrets. Each new study revealed additional layers of complexity in the canyon's story. Geologists began to work out the detailed history of the rock layers, using fossils and mineral compositions to determine when and how each layer had formed. They developed techniques for measuring the age of rocks, gradually building up a timeline that stretched back over 1 billion years. The Grand Canyon became one of the most important places on Earth for studying geological time and the history of life. Let's pause here for a moment and appreciate what the Grand Canyon means for scientific understanding. Nowhere else on Earth can you walk across a landscape and literally see so much of our planet's history exposed in cross-section. The canyon became a natural laboratory where scientists could test their theories about how landscapes form and how life has changed over geological time. The establishment of Grand Canyon National Park in 1919 marked another turning point in the canyon's modern story. For the first time, this remarkable landscape was protected specifically for its scientific and scenic value rather than for its potential economic resources. The creation of the national park system represented a revolutionary idea that some places were so valuable for their natural beauty and scientific importance that they should be preserved for all humanity. But protection brought new challenges. As word spread about the canyon's magnificence, increasing numbers of tourists began to visit. The construction of roads, hotels, and other facilities made the canyon more accessible, but also raised questions about how to balance public access with conservation of the natural environment. The development of the canyon as a tourist destination was both blessing and curse. On one hand, millions of people gained the opportunity to experience one of Earth's most magnificent landscapes firsthand. Many visitors developed a deeper appreciation for nature and became supporters of conservation. On the other hand, the infrastructure required to support tourism had significant environmental impacts. Take another slow, contemplative breath and consider how the Grand Canyon became a symbol of the American conservation movement. The protection of the canyon established important precedents for preserving natural landscapes, not just for their economic value, but for their intrinsic worth as part of our natural heritage. The mid-20th century brought new scientific tools and techniques that revolutionized our understanding of the canyon. Radioactive dating methods allowed scientists to determine the precise ages of rock layers with unprecedented accuracy. Aerial photography and later satellite imagery revealed patterns in the landscape that couldn't be seen from the ground. Computer modeling helped scientists test theories about how the canyon formed and how it continues to change. One of the most significant scientific developments was the acceptance of plate tectonic theory in the 1960s and 1970s. This revolutionary understanding of how Earth's crust moves and changes provided new insights into the forces that created the Colorado Plateau and influenced the formation of the Grand Canyon. Scientists began to understand how the collision of tectonic plates far to the west had created the conditions necessary for canyon formation. The development of new dating techniques also resolved some long-standing debates about when the canyon formed. For decades, scientists had argued about whether the Grand Canyon was very old, perhaps 70 million years, or relatively young, perhaps only 6 million years old. Modern techniques have largely settled this debate, confirming that the major phase of canyon cutting began when the Colorado River integrated about 6 million years ago. But even as some questions were answered, new mysteries emerged. Scientists discovered that different parts of the canyon formed at different times and in different ways. The eastern Grand Canyon may have formed differently from the western Grand Canyon. Some tributaries are much older than the main canyon, while others are younger. The story became more complex and nuanced as scientific tools became more sophisticated. Let's witness one of the most important modern discoveries about the Grand Canyon, the recognition that it continues to change today. Far from being a static, finished landscape, the canyon is still actively evolving. The Colorado River continues its work of erosion, though at a much slower rate than during the Ice Ages. Rockfalls and landslides continue to shape the canyon walls. Flash floods in side canyons carve new channels and deposit new sediments. Modern scientific monitoring has revealed just how dynamic the canyon environment really is. Sensitive instruments can detect tiny movements in the rock walls that indicate ongoing geological processes. Stream gauges record every variation in the Colorado River's flow. Weather stations track climate patterns that affect erosion rates and ecosystem health. The construction of Glen Canyon Dam upstream from the Grand Canyon in 1963 created an unintended scientific experiment in how human activities affect natural systems. The dam dramatically changed the Colorado River's behavior within the Grand Canyon, eliminating the spring floods that had been the river's primary tool for maintaining beaches and backwater habitats. Scientists have spent decades studying how these changes affected the canyon ecosystem. They've documented the loss of native fish species, changes in riparian vegetation, and alterations in the river's ability to move sediment. These studies have provided crucial insights into how rivers and their associated ecosystems function, and how human modifications can have far-reaching consequences. The dam also created opportunities for new kinds of scientific research. The clear, cold water released from the dam created conditions that allowed scientists to study the canyon's underwater environment in unprecedented detail. Scuba diving expeditions revealed archaeological sites that had been buried under sediment for centuries, and documented how aquatic ecosystems respond to major environmental changes. Take a moment to breathe peacefully and reflect on how modern technology has transformed our ability to study and understand the Grand Canyon. Satellite imagery allows scientists to monitor changes across the entire canyon system. Sophisticated chemical analyses of rocks reveal details about ancient environments. Computer simulations help scientists understand how the canyon might continue to evolve in the future. Perhaps most importantly, modern science has revealed the global significance of the Grand Canyon as a record of Earth's history. The rocks exposed in the canyon walls preserve evidence of ancient climate changes, mass extinction events, and the evolution of life that has implications far beyond the American Southwest. Scientists from around the world come to the Grand Canyon to study questions about how our planet has changed over geological time. The canyon has also become a crucial site for understanding how climate change might affect arid landscapes. Scientists use the canyon's long record of past climate changes to understand how desert ecosystems respond to warming temperatures and changing precipitation patterns. This research has implications for predicting how similar landscapes around the world might change as global climate continues to warm. Modern archaeological techniques have also revolutionized our understanding of the human history of the Grand Canyon. Ground-penetrating radar can locate buried archaeological sites without disturbing them. Sophisticated dating techniques can determine the ages of artifacts with much greater precision than in the past. DNA analysis of ancient remains provides insights into the relationships between different Native American groups and their connections to modern tribes. The integration of traditional ecological knowledge from Native American tribes with modern scientific methods has created new opportunities for understanding the canyon's history and ecology. Indigenous peoples' detailed knowledge of plant and animal behavior, seasonal patterns, and long-term environmental changes provides crucial context for interpreting scientific data. Today, the Grand Canyon continues to serve as a natural laboratory for studying some of the most important questions in Earth science: climate change, ecosystem dynamics, geological processes, and human impacts on natural systems. All of these crucial topics can be studied in the Grand Canyon with a depth and completeness impossible in most other places. The canyon has also become a symbol of the importance of long-term scientific research. Many of the most important discoveries about the canyon have come from studies that continued for decades, tracking slow changes that could only be detected through patient, sustained observation. These long-term studies have provided crucial insights into how natural systems function and change over time. Modern visitors to the Grand Canyon can experience not just the scenic grandeur that captivated early explorers, but also the scientific wonder of standing at one of Earth's most important natural laboratories. Every layer of rock, every plant community, every geological feature tells a story that contributes to our understanding of how our planet works. The development of new technologies continues to reveal new secrets about the canyon. Laser scanning creates detailed three-dimensional maps of the canyon walls that allow scientists to study erosion processes with unprecedented precision. Genetic studies of plants and animals reveal how species have adapted to the canyon's unique environments. Paleoclimatology studies use ancient pack rat middens and tree rings to reconstruct thousands of years of climate history. As we conclude this chapter of modern scientific discovery, let's take one final, appreciative breath and marvel at how much we've learned about this ancient landscape in just the past 150 years. From Powell's first daring expedition to today's sophisticated scientific studies, each generation of researchers has added new layers to our understanding of how the Grand Canyon formed and how it continues to change. The Grand Canyon today stands as one of humanity's greatest success stories in balancing scientific research, conservation, and public enjoyment of natural wonders. Millions of people visit each year to experience its grandeur, while scientists continue to unlock its secrets, and conservation efforts work to protect it for future generations. It represents the best of what we can achieve when we recognize the value of preserving Earth's natural heritage while making it accessible for study and appreciation. And so we come to the end of our incredible journey through deep time, from the ancient Precambrian rocks that form the canyon's foundation to the modern scientific understanding that continues to evolve today. Take a slow, peaceful breath with me, and let yourself feel the weight and wonder of the story we've shared together. We began our journey nearly 2 billion years ago in an Earth so different from our own that it might as well have been an alien planet. We watched as ancient seas deposited layer upon layer of sediment, as mountains rose and were worn away, as life itself experimented with new forms and filled the oceans with unprecedented diversity. We witnessed the patient work of geological time, measured not in human lifespans, but in millions and hundreds of millions of years. Through our journey, we've seen how the forces that created the Grand Canyon, uplift, erosion, climate change, and time itself, continue to shape our world today. The same processes that carved this magnificent landscape are still at work around the globe, slowly but persistently reshaping the face of our planet. Every mountain range, every river valley, every coastline tells a similar story of patient geological forces working over vast scales of time. Let yourself rest now in the knowledge that you've witnessed one of Earth's greatest stories. Feel how this ancient tale connects you to the deep history of our planet and to the ongoing processes that continue to shape the world around us. The Grand Canyon teaches us about patience, about how small, persistent forces can accomplish what seems impossible when given enough time. Drop by drop, the Colorado River carved through solid rock. Grain by grain, the canyon walls were weathered and carried away. Year by year, season by season, the landscape was transformed into something magnificent beyond human imagination. This patience of geological time offers a different perspective on our own brief human lives. In the context of the canyon's million-year story, human civilization represents just the most recent moment, a thin veneer on top of an almost incomprehensibly deep foundation of natural history. Yet our species has become a geological force in its own right, capable of influencing the very processes that created landscapes like the Grand Canyon. Take another gentle breath and consider what this means for how we relate to the natural world. The Grand Canyon reminds us that we are part of something much larger and older than ourselves. The rocks beneath our feet, the water we drink, the very atoms in our bodies all participate in cycles that connect us to the deepest history of our planet. The story of the Grand Canyon also teaches us about resilience and adaptation. Over millions of years, we've watched as life responded to changing conditions. Ice ages and warm periods, rising and falling seas, shifting climates and evolving landscapes. Species appeared and disappeared, ecosystems assembled and reassembled, but life itself persisted and flourished through all these changes. This resilience gives us hope as we face our own era of rapid environmental change. The fossil record preserved in the Grand Canyon's walls shows us that life has survived previous episodes of climate change, even dramatic ones. While individual species may come and go, the creative force of evolution continues to generate new forms of life adapted to new conditions. The indigenous peoples who called the Grand Canyon home for thousands of years understood something important about living sustainably in challenging environments. They developed ways of life that were in harmony with the natural cycles of the landscape, taking what they needed while ensuring that resources remained available for future generations. Their traditional ecological knowledge, passed down through countless generations, represents a different kind of deep time, the accumulated wisdom of human adaptation to place. Let your breathing slow and deepen as you reflect on these connections. Feel yourself as part of this continuing story, not separate from the natural processes that created the Grand Canyon, but part of them. The scientific exploration of the Grand Canyon over the past 150 years has revealed layers of complexity and beauty that early visitors could barely have imagined. Each new technique, each new discovery, has added depth to our understanding while revealing new mysteries to explore. The canyon continues to teach us, continues to surprise us, continues to inspire new questions about how our world works. Perhaps most importantly, the Grand Canyon teaches us about the value of preservation, about protecting places not just for their immediate utility, but for their intrinsic worth and for the knowledge they contain. The decision to preserve the Grand Canyon as a national park represented a revolutionary idea that some places are so valuable for their natural beauty and scientific importance that they should be protected for all humanity, for all time. This idea of preservation for future generations connects us to the deep time scales we've been exploring. Just as geological processes work over millions of years, our responsibility for stewardship extends far beyond our individual lifetimes. The decisions we make today about how to care for places like the Grand Canyon will affect people who won't be born for many generations. As we settle into the peaceful conclusion of our journey, take one more slow, satisfying breath, and let yourself feel gratitude for this remarkable planet we call home. The same forces that created the Grand Canyon, the patient work of water and wind, the slow dance of continents, the creative power of life itself, continue to operate all around us, creating beauty and complexity on scales both vast and minute. The Grand Canyon stands as a testament to the power of natural forces working over deep time, but also to the human capacity for wonder, curiosity, and stewardship. It reminds us that we are temporary visitors in a story much larger than ourselves, but that our brief presence can make a difference in how that story continues to unfold. Tonight, as you drift toward sleep, let the peaceful rhythms of geological time carry you into rest. Feel the solid earth beneath you. Know that you are part of an ancient and ongoing story, and rest in the knowledge that the same creative forces that carved the Grand Canyon continue to work their ancient magic all around us. The million-year story of the Grand Canyon is also our story, a reminder of where we come from, what we are part of, and what we have the opportunity to preserve and protect for those who will come after us. In the end, we are all part of Earth's continuing autobiography, written in stone and water, in the patient work of time itself. Sleep well, fellow travelers, and dream of deep time and ancient stories, of patient rivers and enduring stone, of the magnificent ongoing creativity of our living planet. Good night.